Hey everyone, let's take a look at Achieve section 4.2 number 5, where we're finding all the critical points for this function here. First thing I'm going to do is to rewrite square root of t plus 2 is t plus 2 to the 1/2 power. And I'm further going to note that my domain for this function is the set of all values of t where what? The radicand here, t plus 2, must be what? Greater than or equal to 0 in order to get a real output, which means t must be greater than or equal to -2. Okay, when I take the derivative of t is 1 with respect to t. And then here I've got a little chain rule, right? I've got an 8 constant multiple. The outer function is u to the 1/2, inner function t plus 2. So the 1/2 comes down, t plus 2 to the -1/2, right? That's the power rule, times the derivative of the inner function. Well, yeah, I don't have anything there. What happened to that? Well, the derivative of the inner function is what? Is just 1, right? The derivative of t plus 2 is 1. And so this is the result. Let's clean it up. 8 times 1/2 is 4. And then 4 times t plus 2 to the -1/2 is 4 divided by t to the +1/2, which I've went back and just written as the square root of t plus 2. And I can combine these as 1, and that's helpful, and I'll explain why here in a minute. But if I combine these as one fraction, I need the common denominator here. So 1 is written this way, and this simplifies down to this. So this is a good form. Why did I put it in this form? Because I can quickly tell that the derivative is going to be 0 when the numerator is 0. And of course, when the denominator is not 0. But let's see, when is the numerator 0? When this stuff up here is 0. So add 4 to both sides, square both sides, subtract 2, and we see t must be 14. If t is 14, then the derivative is 0. Also, though, remember, critical points are not just where the derivative is 0, but also where it may be undefined in the domain, right? And it's undefined when you're dividing by 0. So when the square root of t plus 2 is 0, t being -2 will make that denominator 0, meaning the derivative is undefined. Both -2 and 14 are indeed in the domain of the function. Okay, even though it's sort of an endpoint, -2, that's still in the domain. So technically, these are both critical points, -2 and 14. Okay, I hope this helps with this one, finding critical points.